So anybody, any questions?
I have a question regarding the term projects. I just wonder what approach, we should start selecting the projects.
Yeah, I think we forgot to talk about this last week. Actually, I realized this. So it's going to be our first thing after probably the homework assignment. So we talk about projects. Okay, so let me just begin once more with the proceedings. As you know, the proceedings is essentially the contribution that you're making to the class as part of your homework and project assignments. So this proceedings will include your project reports as well as all your homework, and is openly shareable with anybody. And in order for us to make it easier for the TAs, I went ahead and added your HIDs after the homework assignments. And so you can then see here, for 141, so you have the number and so forth. One of the things that we would like you to do, and is 141 here online?
Yeah.
Could you be so kind to just go ahead and fix your markdown so all of your stuff looks a little bit dense? And there is no character such as this in Markdown. It's actually a star.
Yeah.
What editor are you using for editing this?
I used Word document and then.
Yeah, that doesn't work. Word is a crappy program.
Okay.
So Word does not work. So we would like that you use PyCharm,
okay,
Sublime, Atom, or something. An ASCII editor work certainly does not work.
Okay.
And Word actually produces very dirty output if you convert it to some other formats.
Okay.
And as you see, is also here the URLs don't come up correctly. So you need to follow our guidance that we have set. This is they need to be included in greater, smaller characters so that they can go. And if you are ever in doubt, you can certainly look at other people on how they do this here, for example.
Okay.
You can certainly click on their thing here.
Okay.
And you click on this, you see their solution, and you can go here on the raw, and there you see how this particular person is doing.
Oh, okay. Yeah, yeah.
Right? So super easy. This person also has made a mistake here. I just see this. This probably has to be taken out. I bet with you that this is not the proper URL on the PDF. So I'm not sure who this person is. This is 144. Is 144 online? So I bet with you if you click on that PDF file here, as you see, this we don't see it, right? And so so what we need to fix URLs with underscore. Okay. And now you see how we comment to you, and then you can just like fix it. Good. Okay.
Yeah.
There was another question.
Yeah, Professor, this is Shreyans. I have a very basic question. I have downloaded the PyCharm for students. It's free for 1 year. So just wanted to check with you. I don't know how to integrate the GitHub with PyCharm.
Oh, so we actually had a video recording on this last week. Actually, I demonstrated this. Let me just show you how to do that easiest. The easiest is actually to create first a Cloud Mesh directory in the terminal. So, and then use git clone. So if you, can you, maybe I create another directory. As
yeah, I know this. I saw your video also on this.
Yeah.
So this will integrate that.
So the first thing is just download it through the command line.
Yes.
So have you done that?
Yes, it's there in my.
So here's what we do: is just let's share your screen. Let's not lose the time because we want to talk about the projects. So I stop sharing and then you share us what you're seeing. And then other people can learn from your experience here.
Sure.
So you go to PyCharm.
Yeah.
You can just type in the loop thing on the right-hand side, PyCharm. Yeah, okay, that's good. And I only have used the community edition. I am not using the professional edition.
Actually,
So
okay.
no, now before you do anything, can you open up the terminal on the bottom? Yeah, and go to the directory where you have your stuff.
The cloning one, I didn't do that step. Okay.
So so one of the things is you need to create a directory called CM.
Okay.
Say CD and then enter. Now say CD and then capital desktop. Desktop is naturally lowercase. You're on Macintosh. A capital D and then desktop.
Oh, sorry.
Okay, enter. Now you can say mkdir CM.
Pardon, Professor?
We are in a Linux system, so we say mkdir CM.
MK, oh, MKDIR. Okay. CM. All
Lowercase.
all lowercase. Sorry.
Okay. Now you say CD CM. So this is now your directory where you do the classwork in. Okay. So now go to your web browser.
Web browser.
Yeah. I use Chrome typically.
Okay.
No matter which one you're using.
I use both actually. Yeah.
So now you go to, you should bookmark the Cloud Mesh community directory at one point. So go search GitHub Cloud Mesh community.
This one.
Yeah.
Yeah. It's
Go in the green button there that says clone or download. You copy that thing. Yeah. You go into your terminal. And then you say git clone. Git and clone are two words.
sorry. I'm sorry.
And
Just
then paste your address in there that you just copied. And then say enter. Okay, now if you do an ls, you have this directory in there, right?
Yeah.
So now you go to your PyCharm and you say open. I can't see where I can't see the top thing. No. Cancel. I can't see where you, yeah, there is an open there. Say go to the open. Sorry.
So the open is here.
Yeah, then click on that open. Yeah.
Yeah, I did that.
And then browse to that directory, which is on your desktop.
Yeah.
And CM, the first one. And then, no. You say open. Now it opens the entire directory. Yeah, I don't know what you're doing, but I don't have that Java problem whatsoever.
It always comes for me. I don't know why.
I don't know why. You have to figure that out. And then you can remove the show tips on startup because they're kind of annoying. And say close. And so now you can browse in the CM directory and you have this stuff in there. Now you can go to data center. You double click on this.
Okay.
And one of the things that you see now is you have on the right hand side your rendering. So now you need to be making some change so that you have a change in there.
Okay, I will.
Add a period behind it or something.
Yeah.
So that you have a single change.
So some reason.
Do you have Vim mode enabled?
Can you type something in?
It's not allowing me to type.
Oh, well, then you have not properly set up PyCharm.
You might have Vim mode enabled. If you press I, you might be able to start inserting text.
Oh yeah, now it's working. Yeah.
Oh, why are you using Vim mode? Is this because you're liking Vim or?
No, default it came in with this mode actually.
Then go to the PyCharm on the left-hand upper side and go to the properties, preferences. Oh, it's on key map, I believe. Right.
It'd be VI.
Go to preferences again and say key map. Go to key map, and then in key map on my version, I have their set there default for Mac OS. See this? Change this to something else. There, yeah. Click on this, and then you can choose whatever you want to have. I have set mine to Emacs.
Emacs.
Yeah, but that's just my default. But the thing is you have set it to the default, but you also have set your Mac to use default Vim mode. So that's something I don't have any control about, nor does PyCharm. That's something that you have done.
So I think now it will work.
Yeah.
That.
Yeah. Okay. So now you right click on the data center. .md file, not there, in the file browser.
Here it's right?
No, on the left, there, right click.
One second, it's double.
So now you say Git, go to Git. Now you say commit file. Now you put a git commit message in there, added a period. Sorry for my accent, is add like ADD.
Okay, sorry, I'm sorry. Oh. It's a little different actually when I'm typing.
Well, I don't have that issue that you have. Maybe it's related to your Java problem that you see. And then you say commit. And now you right click again. And now you go back to Git. And you go to repository. And you say push. And yeah, and you need to be putting your username, and hopefully it doesn't show us your password.
Password should not show, I think.
Is that really your username?
Yeah, I don't think you need the
You
second.
can use anything, email ID or.
Well, but we are not using IU GitHub.
No, I'm not using IU GitHub. I use my email ID as in. It's not IU.
This will not accept it because you have an @ sign in the username, and that's an illegal username.
One second.
Oh, if it does,
Yeah, because it is alias of.
Okay.
My email ID is alias, so you can enter user ID or email ID.
Okay, and then naturally, what you want to do is before you start working, you want to make sure that I haven't actually changed your stuff. Okay, so you right-click actually before you start working on datacenter.md, and then go to repository, the Git repository, and you say pull. And then you say, yeah, run this. This way you pull whatever is in the current online directory.
Got you.
Now, the one thing that you can actually do is you can go to your FA folder, and you can do the same functions there. You can do the git pull there, the commit there, and so forth, and it will be just picking the ones that you have changed. So this way you can make multiple changes or multiple pulls, so you don't have to do just a single file.
We'll do what, all the files together then. Okay.
Yeah, yeah. So you make another change in your data center file, put another dot at the end. Now go to the directory, right click, say git commit.
There must be a short key also.
I'm sure you can configure this. I don't know. Git commit directory, it's the first one. And then, yeah, add another period. Now you can say commit, because that's what you'd have done. And now you say push. And there is a shortcut, at least for the push. Okay, that's all there is.
Thank you, Professor.
Yeah. Okay, good. Good that we talked this once more over. You are learning how to use Git, because you will be using Git for all your programming, because we are accepting nothing else but any code that's in Git. We will not review anything that's not in Git.
Okay.
And yeah, so we are using BibTeX in a future assignment so that we know how to do this in a Markdown. Remember, we have about 16 weeks or 15 weeks or whatever is left over, and you know, we can't learn everything in the first week. So we really need to be splitting this up, and we gradually improve things. So at one point you will see that we will ask you to resubmit your data center assignment to test out certain things on, for example, more advanced features such as bibliography management. But then once you know how to do this, you can do this for your report. Good. Okay. Cool. So one of the things we also pointed that out is there's a flood of plugins available. So I have, for example, Makefile support, because I use a lot of Makefiles. I have the Markdown Navigator from Vladimir Schneider, but there is another Markdown support available. The most useful one I find is the wrap to column, because I can wrap easily to column. Then naturally I have the bundled things which are coming actually with Markdown, like Git and GitHub, and those are things which are coming. And I for example disabled Subversion, but I can also do shell scripts so that I can run things in there. And I have a Python terminal so that I can open up a Python terminal. As you can see, this is quite nicely here. So I can here, for example, be in the terminal. I can say ls there. So whatever I can do there. If you, for example, have a problem with real estate, you can just open that PyCharm window here with the green button in Macintosh, and in Windows is probably something else. But you have then down here windows that you can utilize, and you even have here like to-dos. And as you can see, I have 4,337 to-do items in there, so I can solve them all by tomorrow morning. so you can add to-dos in your thing, and there's a Python console in there, you know, which you can utilize, and you can put them here nicely if you wanted to do them. Okay, so PyCharm is really good, and as you can see, this is here. I'm standing here in this thing, and I've put here this smiley thing in there, and it renders in this old fashion. So it doesn't mean that if you render, if you can see this in here, that it's properly rendered. It just means it's approximately okay, right? So we still have to go through this. One of the things I've actually done is when I go, for example, to 166 here, I have a program installed, MDL, and I posted this just a moment ago. And I can actually go to data center, and it shows me all the issues that this particular thing actually has. So for example, in line 11, there's a trailing space. So if I were to go back here, I see this is actually pretty badly formatted. With the block format, I can actually format it. This also removes this particular space. So if I'm running this again, the trailing space has been removed by that other plugin even. So I can go to line number 46, do the same thing here and here. And as you see, it doesn't take me any time to do. So these are all features in Markdown. And as you can now see, it's 46, there's a trailing space. So where would that be? Well, it's probably back here, somewhere here. As you see, there's a trailing space. If I run this program again, it's now 71 is one. So if I go there, as you see, this is the trailing space here. And now as you see, there's still one left, I guess. So now the trailing spaces are all removed, as you see. And then there's only line number 23, which is a little bit longer. So let's see here, this one. So I break this over. So now this thing passes now the Markdown test. So install the MDL program. Since you guys are all going to be programming, this can be installed under Windows, this can be installed under Linux, this can be installed under Macintosh. So there are different ways of installing this. I recommend you cut down your time. So, and then what I do now is we showcased how one other student committed. I can now say git status in the command line, showcasing me what actually has changed. So they see that there's this file. I can also say git diff, showcasing me all the differences that I actually have here created. In red, you saw what was there before. In green, you see what I have changed. So this way, it's very easy for me to review these changes. And if I'm happy, I can say git commit -a. I open this and simply say this is reformat entries, or reformat Markdown based on MDL feedback. I save this. I say yes. I say git push. But before I worked, as you now see, there is a git pull. I should have said git pull from my repository, and there is a conflict now. So I actually did this on purpose. So I can now go into my data center section here. And as you see, there's one section here at the end that you see has a slight difference. And what I do is I have to remove these things and reformat them. And now I have resolved the conflict. And what I need to do next is I need to commit my new version. So I say git commit -a. This will now merge my current version that I fixed into the version that I would have normally gotten from my repository. And now I can say git push. And so this new version is now in the repository. I can do git pull or git status, just to make sure. And as you can see, I'm now fine. And if I were to go to here, this was, I think, 166. So I can go to 166 here. And as you now see, if I go to the data center section here, or program, all of this has now been formatted nicely, but I can't actually see this. I can look at raw. And as you now see in raw, everything is beautifully formatted. Okay, any questions concerning this? So and this is how do you interact on the command line with this? So we have three ways. One, where you use the pencil, but then you really need to be making sure that you use whatever is at that time in that document, not locally. Then the one other thing is you always do a git pull to get your documents from the remote repository. Then you do the modifications, you do the git commit, and then you do the git push. So this is the workflow. And listen to this recording if you have difficulties. Look at this. This is really super simple. So do we have 140 online? 141? 143?
I'm 141.
You're 141. Yeah, we already mentioned that you need to do the markdown.
Yeah.
Okay. 143? 144? 146?
I think that's me. 146.
Dallas, City, Oregon. Okay. Yeah, I don't see there's not much there. What was 8? What was the assignment 8? Do you remember?
That was the data center outage. I pushed that earlier today. So yeah, that should
make sure that I didn't override it by any chance. Okay, just
okay.
It could naturally be is that I haven't synchronized with what you just had. I updated this document an hour ago.
Okay.
For whatever was in GitHub, I've gotten from an hour ago.
Yeah, I think I pushed around the same time.
Yeah, so maybe it wasn't in there.
Yeah.
Okay. I will update this, no problem. So then 147.
Yeah, Professor, that's me, and I think I have latest push, which is.
Yeah. So what you have to do is you have to put these URLs in quotes and then use proper, either unordered lists or ordered lists.
Okay.
Then 152.
Yeah, hi, Professor. I'm here.
Yeah, just the same thing here. Just use proper lists so your references they don't look that beautiful. 155.
I'm here.
Yeah, I love that image. So so I think that's really a good. So you found really some good information there.
Thank you, Professor.
156, and this doesn't mean that the other people didn't find good information. It's just I really like that image because I actually haven't looked at this for a while, and then I remembered, hey, Facebook has this information actually printed. Do they have this actually for different data centers?
Microsoft.
Yes.
Yes. So and none of the other students came on the idea to just look at your thing and just like replicate this for a different data center. Okay, it was just a thought, right? 156.
Yes, I'm here, Professor.
Yeah, so same thing here. So just use the lists, and then naturally, this is so as you can see, is your references don't show up. Okay, so make sure that you have the URLs properly done. Here, for example, if you do this as a URL, then there needs to be quotes around it.
No, actually, I put the references down below. If you come down,
But u42u.com is a reference. You even call it reference.
No, yeah. If you come down,
okay.
I think it's in the top. Yeah, top of the page.
Well, as you can see, is you have some challenges.
Oh yeah, okay.
And then and naturally, if you call it ref : something, then it should be with the bullet points, so that we can look at it. So
okay,
it may look good in your raw file, but it doesn't actually look good here. And
yeah, got it. I'll make the corrections.
160, I guess, has still.
I'm working on it, Professor.
Yeah,
I'm going to
good. Okay, so make sure that you get that done as soon as possible.
Yes.
162. also nice picture here we got. So we have here our handmade sources, and we will be discussing how do you actually do this correctly so that your reports follow scientific standard. So they're typically with numbers like this, but the numbers can be generated automatically. So we will teach you, maybe not this week or next week, but the week after that, how do you actually do that? And there's already one example in there that does this with whom I've done this. Is that student here online? No, okay. 163? 164? 165?
Professor, I'm here.
Yeah, see, as you see, as your URLs don't come up in blue, so you have the same problem like the other guys have with the greater and smaller sign.
I see. Thank you.
So 166 has an issue with the image because this image is not actually stored locally. And so I need to be figuring out who that is and talk to that person. Okay, there was one problem that I just overlooked, and that's this table here. It's 162. Is 162 here? Okay. Yeah, good. So what will happen is the TAs will start looking at these things. They'll probably take a week to grade these things. Remember, these are just pass and fail. So they may not look at this stuff tomorrow. So I would say this is go ahead and improve your URLs if you have something like this, or if you need to be adding something, just add this. Well, I will locate it, and then we'll point out at one point how to do this. Because one of the things that you can see here in the end is you see these references here, and this has been automatically generated for one of the students where I showcased how to do these kind of things. But I will point out that assignment so that you can learn from that.
Hi, Professor. I have one question.
Yeah.
See, you pointed out on the URL side, and I do see when you are showing this, it is not coming as a like a hyperlink kind of blue.
Yes.
But when I see in the GitHub, even in the
GitHub doesn't use Markdown.
Oh, so that may be the reason why
GitHub renders something completely different. So what we are doing is we are using Markdown, and in Markdown, the proper way of doing URLs are with greater equal signs. And what GitHub does is GitHub has a modified version of Markdown. They make it a little bit smarter and says, okay, if you forgot the brackets, we put them in for you. But that's not really Markdown. Markdown does actually require you to the brackets. If you want to figure out the real format, we are actually using a tool called Pandoc, and then you can look Markdown. So if you look for Pandoc Markdown, that's what we are using, and there are various flavors of Markdown available, and we are just using the plain Markdown flavor. And this is here our Markdown document. So let's do this, and then but that's not bad. So I will not pass you if you have a Markdown error this week. Next week is a different story. So here you have the description of how Markdown actually looks like, and then here's the basic syntax that they use. And at one point, I think they're rendering you here links. Here's an example for hyperlink. And I don't know if they even do, oh, okay. Yeah, I don't see the greater equal, but in Pandoc it's greater equal, so around it. By the way, we have the scientific writing book that you may want to look into, and there is here also this information in there. And I today added the also the hyperlinks a little bit better,
so that you can find them there. But there's also information about, how do you avoid plagiarism and those kind of things. So that's a good read at one point if you don't have anything else to do. Go quickly through the Python book. So the Python book, you guys have already started working on this. And so the expectation was that you start looking into Python. Naturally, you can't become a Python expert by tomorrow. So you will be needing some help on how to do this. You're supposed to have Python 3.7 installed like a week ago or something like this. And now we start Python with you together. You can use either Python 3.7 from python.org or the Conda version, whatever is more convenient for you. Just make sure that you use in both cases a virtual env. And we have described this, I believe, in both frameworks. Here we describe it for Conda, and here we describe it for Python 3. And as you see, this is the Python 3 version is significantly simpler than the Conda version. So you don't have to do multi-version Python if you don't have anything special. Or the need for Python 2 for other projects. If you do, you can contact me and I can talk you through this. Or you can actually follow our instructions on how to do this.
Hey, Professor, real quick, I have a question for you. So in regards to the Python install, what's your take on using like an online Python editor like Google Colab?
Yeah, we will be actually using at one point Google Colab.
Okay, cool. Okay.
But Google Colab typically does IPython notebooks.
Yes.
And one of the problems that we have is that works actually very well for using the Google services, which are cloud hosted. So we will be using them.
Yep.
But if you were to stage your own virtual machines on other clouds, naturally you don't have Google Colab there. So you will have to download the Python program, modify the Python program, because I've actually seen that most examples like the MNIST project that we actually just uploaded today, I don't know if you have looked at that, this is we have the first Google Colab code actually in our book, but it's not public. If you look at the MNIST implementation, they typically do a Python 2 version of this. And what we want to do is we want to do a Python 3. And then I've actually told the TAs today to integrate some of the lessons that I'm teaching you this week into the MNIST example, such as, for example, how do you benchmark? And we have a super easy ways on how to do that.
Because I thought Colab had Python 2 and 3 options.
Yeah, it does. But the thing is most people, what they do is they still program in Python 2 despite the fact that they use Python 3.
Oh, okay. Got it.
And what I want you guys to understand is we can just go with Python 3. I don't think that I have a need for Python 2 at this time. Okay.
Okay.
But if I'm mistaken, please let me know. If there's some tool out there that requires Python 2, let me know. So the one thing is you probably have already Python knowledge, or if you don't, you should probably do the chapter 4, figure out what the interpreter is, and then we have here a tutorial that's a little bit older, but it's still up to date. It may include some things that are not important for you, but you can abstract from this, and that actually shows you how to run a program in PyCharm. So there's a tutorial that says how do you learn Python in 43 minutes and 16 seconds. So you can take a look at that one. We have the language feature, so where you learn about print variables, modules such as date, time, and so forth. It will take you a bit to get used to this if you haven't done actually any Python. Then there are modules such as pandas that you may be able to use and are allowed to use, but sometimes they're actually quite time consuming or slow in some sense of loading it. But once you load that, they're actually pretty fast. Control statements like if conditions and so forth, so you should be reviewing this. Data types, there are naturally lists there, but the most important data type is actually a dict. And so you need to be learning how do you do dicts, because everything in cloud computing is literally controlled through dictionaries. And the dictionaries are formulated either as JSON object or YAML data structures. So that's really, really good for you guys to look into. And then there are key values and so forth. And so take a look at that dictionary section. That's really helpful. Functions, naturally, I mean, you know how to do functions, I guess, you know, in any programming language. Here's how you do this in Python. And some functions return a value. Here, this one here doesn't even, here this one prints something and returns actually a value. And this print statement here, I just realized is wrongly indented naturally, right? The indentation needs to be 1 over. So there's a slight bug in the program, okay? And here the result, you know, when you print this but you return the value, here these two values need also to be indented. So if you want to fix this, you can fix this and we integrate this. So some people have already helped us improving some of the programs that we have. Okay, then it's not important that you understand lambda expressions at this time or iterators or these more advanced concepts such as generators. You can read them, but you don't have to understand them because they are not that essential for our class. This section here is now really important because you will be going into Cloud Mesh, and this will be your next homework assignment. And essentially what you do is you will be creating a Cloud Mesh command, and we will be teaching you through 8 or so assignments how do you get there. And we discuss how to install this. And this is really important. So I had in a previous class students, actually it was even in this class here, a student asked me to install this Cloud Mesh earlier, and he has successfully done this, but he used pip install for it. But since we are developers, we don't want to install Cloud Mesh with pip. So I wrote a developer install program that's called Cloud Mesh Installer that downloads a variety of repositories that work with each other. And the previous students had created the CM directory. And what we do is when you're standing in the CM directory, as you can see from this document here, we install pip installer, then we can list the bundles. And in our case, for this particular assignment, we are interested in the bundle called CMS. This downloads the entire bundle CMS into the CM directory. Remember, you must be standing in here. It's important that you read this. Some people are impatient. They just paste and copy this, but there's text in between that you need to be reading. You cannot just go out and paste and copy these things. You really need to read this stuff in between. And then the other thing is this is a really special way of installing it so that when you were to do a git pull out of the directory from that particular bundle, you don't have to recompile the code. The -e option here is really super important. And one of the questions we'll ask you, it's a non-graded question, what does pip install -e dot do in Python? So that would be something that you can do. Once you have installed this, as you see, this are 5 or 6 commands that you have to do, and 2 of them are related to creating a directory, then you should be able to say CMS help, and Cloud Mesh would be able to be set up. One of the next things is we want to then try out some of our special functions. And here are literally the programs. You just have to put them into a program and run them, right? And so there is also some explanation what these variables are. Then you have a banner. And what I want you to do is try these functions out in a little Python program. Here's the heading stuff. Then one of the most important functions that I found for myself is the function that I wrote. It's called verbose. Assume I have a dictionary. Sometimes I need to be doing like a print of a dictionary in a nice form. And this verbose does actually do this. Not only it actually prints the dictionary, but also the lines and also the file name in which you have used the verbose. So if you have many, many different files, if you use the verbose thing and you print the dictionary, it will actually tell you some nice information. Then we have a dictionary. So I want you to read over this. I don't want to explain this right now. This is super useful. So typically we write dictionaries like this, but there's also a dot notation that we can introduce. so that we can say data.name, where name is then the name of the key in the dictionary. So this is quite useful. Then I've written something that's called a flat dict that takes a dictionary and flattens it out. So if this is the original dictionary here, this is the flat dictionary. As you can see, its name is the same in both, but address has address of city, address of state. So what this thing does is it creates address.city as an attribute and address.state. This helps us in certain circumstances to easily print certain things. We also have functions that print dicts or arrays or lists of dicts of the same format. Let's assume we have these two people here in the same format here. So what we can then do is we can just print with the printer function here. We can redirect the output to a table. And here we are flattening out the dict and, for example, print the name and address and create headers, name, street, and city. And so you can then print that table in a fairly easy fashion. Other things that we have is a shell command. This executes on your computer the shell command that you would normally type into your terminal. For some functions, we have equivalent Python implementations. If this doesn't work on your Windows machine, you would be probably responsible for implementing some of these on your Windows machine. You don't have to do this right now. Most important is that you try out the execute function to execute something that you know exists on your Windows machine so that you can see that this stuff actually does work, such as, for example, SSH or dir or some function like that. There's a whole bunch of functions in Linux available. And again, if one of those functions, if you ever were to need them and they don't exist in Windows, then you will have to power implement them. This is the most useful thing that we will be using. We have a stopwatch. And let's assume I want to measure the time between a particular session or of a statement. I can set stopwatch start and the name of the stopwatch, stopwatch stop and the name of the stopwatch, and then get the value. But I can have many different stopwatches. Unfortunately, this is only working in sequential, so this is not working when you're in threads, but so it needs to be used outside of threads. But at the end, I can say stopwatch.benchmark.print, and that's what I need you guys to do to test out so that you can feature this. One of the nice things is we have in each one of these chapters here a link to the manual, and the manual describes how these functions actually work. So there's a documentation provided. If there's something wrong documented, let us know or fix it. Then this is the main assignment where you create actually a shell command, and CloudMesh has a command shell as well as a command line argument. So when you type in CMS, it's the shell similar to a MATLAB shell if you so want. But if you type in CMS and then the command help here at the end, it's just a normal regular command. And the nice thing is I can actually create new commands for the CloudMesh shell. And here's an example given. And I want you to run through this example and use your own first name for the example and create yourself your own program, because this is how we start up some of our programs because we add that and integrate this, for example, in CloudMesh shell. So that's basically it. And then the exercises are listed here. And as you know, we published a new 516 book today that refers to these exercises. So there is no confusion possible. We have everything in here. When you take a look at the book, for example, let's just actually, you can go probably to my web page even. Let's just try that. Or actually, let's go to Piazza. That's a good thing, so that we don't get lost. So Piazza. Oh, I'm lost. Where do I have to go? Oh, resources. Okay. Where do I have to go? Okay. 516 lecture notes. That sounds like a good thing. Where do I have to go? Well, I'm clicking on the PDF. PDF is the EPUB is downloaded. and it's popped up, and then I can look around here and I can search for week number 3. And these are our assignments for week number 3. This includes reading the section about the architecture. There's no written assignment about the architecture because I want you to spend now time on Python and make sure that your Python environment is all set up so that we can start programming. And the shell exercise, these here are like bonus exercises. You basically have to pass and copy. But this here require a little bit more time investment. Again, how much time does it actually take? I don't know. I have done the whole set of exercises in 30 minutes. I would, however, assume that, with you trying these things out and maybe not as familiar with the things, if you spend more than 4 hours, then really do contact us because you probably are doing something wrong. And then naturally you spend 2 hours reading the architecture chapter. Are there any questions? Because then we can move on to the projects.
Professor, we do the exercise just for ourselves, or we have to?
No, these are graded exercises. So one thing I like to repeat this again. This is the first year I'm actually assigning graded exercises. And the reason for this is because in the previous class, we had one class where the students did not spend any time on our exercises, and then later complained when we assigned the project, or when we discussed the project, they didn't know what to do, and they were confused, and they didn't have anything because they didn't follow the entire semester the class. 1 week before the project was due, they came up to me and said, "What do we need to do?"
Okay, but do we have to put this program in certain place, or are you going to review?
In GitHub. There is a documentation provided in the Python book that describes how do you name the directory.
Okay, thank you.
Yeah, so very good question, super good. But if you look at this particular book, as you've seen, you can actually click on this, and you go back to this, and you can open this thing. And if you go here to the section that has that particular activity in it, I should have bookmarked it. Here, it states on top, how do you actually name this? So if you, for example, have an exercise that's called e-cloud-mesh common 1, then you name the program here, e-cloud-mesh1.py.
So each exercise is one file, 1, 2.
Yes, I think to make it easier for the TAs, but you could, the first one, all the common ones, you could just put in one single program. Yeah, all of these till 5, you could just put in one single program. Okay. You could call it e-cloud-mesh, e-common, or e-cloud-mesh common.py. So you can be inventive with this, but make sure that you put in front of the exercise at least a comment that says this is which exercise is being addressed by it.
So, Professor, so because this is going to be a program in Python, can we just use a Python notebook and publish that out to GitHub?
No. What I want you to do is I want you to use a Python program with Python file and not an IPython notebook.
Just a py file, okay.
A py file. And the reason is simple. I have actually had in the past students that used IPython notebooks and they couldn't write classes because they never did that in Jupyter notebooks. Mm-hmm. And Jupyter notebooks encourages you to write functions, but it doesn't encourage you to write classes. However, one of the advantages that we have here is our CloudMesh shell leverages actually classes, and it's just too complicated to put this into a IPython notebook. Once you, however, have developed that, you can certainly put that into an IPython notebook, but you first have to develop it in a py file.
Okay, that works. And so would you take the Py file and then put it into GitHub and then give it a name like, you know, pound e cloud mesh common 1?
Yeah, yeah.
Okay.
Yeah, so just take a look at the text. If you don't, if you can't make sense of this, common sense sometimes just prevails. So we are having a great deal of flexibility, but I don't want that you're using IPython notebooks. Okay, good. So now coming back to the. So there's these exercises here. Now the project. So I've thought I didn't release the project's description earlier on too much, other than on the first day of class, you had already a link to the Cloud Mesh manual that had certain projects listed. So if you, for example, go here to this link here, there are certain projects listed that nothing has changed here. So you can look at these. These are very straightforward projects that you can do in this particular class, and you can choose them. The easiest project I find is probably the Cloud Mesh Compute project for developing the compute interface to Google Compute Cloud. That's the easiest project I think we have. And then second one would probably be the storage project, and then it goes on from there to be a little bit more complicated. This is, however, just a list of projects that I thought may be easy for you guys to do. You can do arbitrary complex projects. You should make sure that this project is not a PhD thesis, right? So just, we want to be reasonable, right? So this should not take you more than the required hours per week to work on this. So when we refer to our document, what I have done here is I have given certain requirements. And these requirements are based on what we teach you in class throughout the entire semester. So if you follow the graded activities, you have already a quarter of your project identified, because we refer to graded activities that you have done anyways, but you can use these graded activities to extrapolate and to integrate them into your project. So this is really good. So this is the good news. So that means throughout the semester, you will be learning certain things, and you can just put them aside and they will be showing back up into your project. Not all graded activities will naturally show up. So here's what's actually happening is one of the things is we have a great deal of experience in Python, and we found that any program written in Python is much smaller than any other programming language that we can come across in. So we would like you to do programming in Python. There is one group that actually discusses with me if they can do their project in F#. There will be some portion of that particular project in Python, but they need to be motivating why they do need to use F# and cannot do this in Python, for example. So if that can be motivated, that's clear. One of the problems we have is we don't actually have anybody who's able to grade this, because any other programming language that we use will be taking a little bit more time. There could be an argument for Java, but if you were to do Hadoop, but even in Hadoop, if you look at Spark, Python seems to be faster than Java. So you know, I want to use Java. Does not, because you use MapReduce and you want to do this in Java, may not be the argument that you want to bring forward if the framework that you're using has a faster library in Python. Okay, so you need to be researching that. Second thing is we will be teaching you how to write a REST service in OpenAPI 3.0 standard, and every student will be having to develop such a REST service. Any project that we have, regardless if you use Hadoop or Kubernetes or virtual machines, everybody needs to write such a thing. So we will teach you how to do that. The next thing is this REST service will be written in connection. So it's going to be done with Python because it's a 3-line program. And you will be blessing me that I allow you to do that instead of you defining it from scratch. We will teach you how to do that. So no problem there. The next thing is we need to be addressing cloud services like a provider, such as Google, Amazon, OpenStack, and so forth. And if you're a single student, you have to use 2 clouds. You pick the clouds. If you are 2 students, you have to do 3 clouds. If you're 3 students, you have to do 4 clouds. So that's very simple. What the cloud means, it doesn't mean that it has to be virtual machines. It could also be Kubernetes and stuff like that. So we can be flexible about this. The code must use PyTests in order for you to verify that your code actually works. So when you are actually executing your code, you will be writing test programs, unit test programs that check actually, okay, is the functionality that I've implemented really do work? And the teaching assistants will probably execute your PyTest and evaluate if your stuff works. If something that you have developed is not working and you have a PyTest for that not working code, you get a positive point for this. If you, however, have a feature that doesn't work and you don't document it, you get a negative point if you don't document it. You understand, right? You can have things that don't work, but you have a PyTest and you demonstrate that it doesn't work, you get a point for it. If you don't do that, you don't get a point for this. Your code must be using the sysgenerate, which we teach you this week. So you will be doing that. The code must be using the benchmark and the stopwatch, which we teach you this week. You will be using an AI service at one point, such as one from scikit-learn and maybe even Keros, and contrast this potentially with AI services offered in the cloud. This may be optional, I don't yet know, depending on if you, for example, were to use Hadoop. So you may not actually have to do this, but Hadoop is kind of boring in that way. So we may want to encourage you to do AI services. You don't have to understand the AI service. You have to just know how to use it. So we don't teach you how the AI service works, but we teach you how the AI service can be used. So you must be providing meaningful benchmarks, and you must write a report, and any project that's related to CloudMatch is exempted from a report. The only thing that you have to do there is the manual page. But the manual page could be also meaning substantial work. Here are the examples. And then if you do the Raspberry Pi cluster or the robot board, please contact me. I will be setting up separate meetings for you guys so that we can discuss this. Remember, this project takes up to 12 weeks. If you start 1 week before the project, you will for sure fail. And as you see, this is all the assignments that we have done here. We will teach you how to do OpenAPI. We will teach you how to do connection. We will teach you how to get to a cloud. We will teach you how to generate a command. We will teach you how to use the stopwatch. We will teach you how to use scikit-learn and Keros. So all of these things are all covered in the class. So if you carefully participate every week, that project should be much easier for you, okay? So then,
Professor, real quick, can we pause for a second? So if it takes 12 weeks to complete the project, right, and then it says the assignments will be, the lab will be shown like for a week, like at what point in time will we have like all of the knowledge to proceed with developing the project?
oh, you can already start now.
Okay.
So the goal is that through the 12 weeks you gain that knowledge. Whatever knowledge you don't have for your project, you will be starting, and you may actually look at this ahead of time, maybe even out of band from the class if you were to so choose.
Okay.
But there is the problem I have is I have to give you some assignment, and I have to teach you 12 weeks something.
Yeah.
And some of the material may come very late in the semester. So if you were to, for example, choose the Cloud Mesh project, you already started this week because I'm teaching you how to do the Cloud Mesh project. If you, however, start the Hadoop project, or if you do Kubernetes stuff, or use AI services, you will be learning them later on in the semester. So you may have to look at some stuff yourself before you start this. So I have given you an easy project that actually starts now. If you want to use anything outside of this, you know, it's not my fault that you choose that project.
Fair enough. And then, yeah, that makes sense. Okay. So if 12 weeks from now is like what, December 3rd, we should probably get started with an easy project probably as soon as possible.
Yeah. Basically what I'm saying is do this assignment this week with the Cloud Mesh generation of the command. This way you already know how to integrate, for example, advanced stuff. And then next week we will be running virtual machines on OpenStack. And all those that were to choose, for example, the Cloud Mesh Compute or Cloud Mesh Storage project can start next week.
And then one more follow-up question. Is there a sample project we can look at for reference from like maybe a previous class or a template?
Yeah, the Cloud Mesh Cloud project.
Cloud Mesh.
So since we're already here, the students are still working on this a little bit. So if you download Cloud Mesh has a lot of directories. So there is this common thing that we try to introduce you, but they are currently working on Cloud Mesh Cloud. And in Cloud Mesh Cloud, we have an abstract class that we call the compute node. And in this, naturally, we want to start virtual machines. I haven't actually given you any introduction about virtual machines, but in general, it's easy to understand. We need to be starting somehow a computer. We need to stop somehow a computer. We need to figure out what is going on in the computer. We want to potentially suspend it. We want to list which computers I have. We want to resume a computer that I have actually started. We want to maybe destroy or kill a computer. We want to create one with some parameters. And then we want to do certain additional functions, which we will be teaching you, okay? And as part of your project, you will be figuring out, okay, you know, how do I deal with SSH keys? How do I deal with security groups? How do I deal with images? And so your project would be going about and doing this. So what this particular group has actually done is they have developed under, so all these other commands have actually been done by me and some other people, but they are currently working in this, mostly in this folder. And in this folder, they are currently working on, for example, the Azure provider. So in the Azure provider, so what they do now is they develop the provider and say, okay, what kind of statuses are existing in the virtual machine? What should I print out maybe in a table? Remember the print statement that we gave you today? This is using that print statement, just the flattened dictionary, just that I put here some values in for doing this. And the students have selected these as valuable information to be printed out in that table. And then what they naturally then do is they implement these functions. And as you see, the key is not being implemented. So this particular group does not yet have in that particular information, or how to delete a public IP and so forth. Because this particular cloud doesn't even want you to do that, right? So, and then in there, they are creating a function, for example, for what it means to create a virtual machine here.
Yeah, so I guess my question was more or less around like an example final project. So if we got 12 weeks remaining to complete the final project, was there like a project we can use for reference, like a previous class or a demo?
Yeah, this is the project.
Oh, so that, oh, okay.
This is actually, what I'm telling you, this is what these people have implemented. This is their final project.
Oh, I see, okay.
So what they and this particular group of students literally only spend time in this file, most of the time. Let's say 90%. So they developed this file.
And Professor, you review the project every week, like a phase by phase, or it's going to review by end of the
No, what we
weeks?
want to do is we want to actually just talk about projects as soon as we start this, and then the Cloud Mesh people can have anytime a meeting with me because in case you get stuck, I will be able to help you. In case you were to use Hadoop or some other project, you may get less help from me, but maybe from the teaching assistants.
And so one more question real quick. So I thought we had to have like PyTest. I thought there was like a...
Oh, yeah. So here the thing is, so not this one group actually developed Azure. Another group developed Docker, that was me. I also developed OpenStack. And then another group developed here AWS. The AWS is pretty well developed. Here we have the same thing. So this looks just like the same, like the Azure thing, just that when we start the virtual machine, it slightly looks different, okay? Now Cloud Mesh has the feature that because we are using the compute node abstract database class, everybody, Amazon, Azure, OpenStack, has the same functions. Because we have the same functions, I developed a mechanism for us to load up this particular cloud provider, how we call this. And we have a test developed, and the test here contains out of 6 different tests. So there are 8 students across these different clouds. They're using exactly the same test from cloud to cloud. So they have then here, for example, a test saying, okay, how do I actually test the list function? And there is a benchmark saying benchmark start, benchmark stop, get me the data, print me the data. Now they say, okay, create me a virtual machine here. This is how you create a virtual machine. Is this particular function. They put this benchmark around this whole thing and test out how their command actually functions. Now they do this for all of these things. And at the end, they just print out this benchmark information.
So there's no defensive coding or exception handling. This is just a straight raw test.
In this particular case, it's just a straight raw test. Yes.
I got it. Understood. Okay.
So we want to not make this too complicated. Okay.
Yeah.
Inside the code, you naturally have exceptions, so that may actually deal with some things. But we don't want to make this too complicated. Like for example, one of the interesting features, if you were to use OpenStack, OpenStack is the easiest cloud to use from our purpose, from the way we actually approach it, and it's the cheapest because we don't charge you anything for it, right? The only problem that we actually have is because it's so popular, it's sometimes oversubscribed. So only 70% of our virtual machine startups will actually succeed. So we have to at times, you know, look at these tests in a slightly different fashion, right? Because if your test doesn't run because the cloud is overutilized, we shouldn't punish you. Right?
So I guess big picture, I want to step back for a second. Is the goal of everyone's project to be a contribution to the Cloud Mesh application?
I think if you do that, that's the easiest project. If you don't do that, which you can do something completely different.
Okay, got it.
But you may end up spending a lot more time.
Okay.
Because you have to set up the cloud, you have to set up Hadoop, you have to figure out how do you benchmark Hadoop, then you actually figure out, okay, Hadoop runs on Amazon, but it also runs on Azure, then you have to get 2 accounts to compare them. And so it's not necessarily an easy project.
And then I'm going to also assume that for the cloud accounts, we're going to be limited to the free tier for Azure and AWS.
You can purchase as much as you want, but I would recommend that you just use the free tier. Whatever the free tier gives you is sufficient for this class. if you have to spend, there was another student that we had, this other student said, well, I spent $200 on my class and on the things. And I said, well, yeah, that's your choice. You could have chosen the OpenStack cloud, cost you nothing.
And let me ask one more question in regards to the cloud. So I know a lot of cloud providers have data centers in different regions, and not all the same regions have similar functionality. So when we do our testing and development, is there a certain region you want us to use per cloud?
No, actually, the free tier is dependent on the region you are in. So
well, you can change your region.
No, you cannot. In order for you to get the free tier, for example, in Amazon. So I can only get the free tier on the East Coast. Well, someone in California can only get the free tier in California.
Yeah, so if we use like some of the IU computers, right, like the servers there, we can open it from there. So it's dependent upon the location of your IP, where you're coming from. So yeah, I mean,
yeah, in Amazon, yes.
Yeah.
And one of the things is we have a configuration file for Cloud Mesh where you can say, go to that region. It's a one-line change, and it actually goes out and changes the region. But if you were to then have the free tier, but you're not in that region that allows you to use the free tier, you cannot start the virtual machine, it will fail.
Okay.
But that's an Amazon feature. That's nothing to do with Cloud Mesh or anything like this.
No, yeah, you're right. No, it's definitely Amazon AWS.
Yeah. So they have certain restrictions.
Yeah, they normally connect to Ohio Center if you're in Indiana.
To which center?
Ohio.
Yeah, see, I'm in Orlando, Florida, and so I normally connect to US East 1.
Yeah, I also have, I think, US East 1.
They recently opened, I think, I recently opened my account, so my default free account is in Ohio Center now.
Oh, wonderful. I have to double check. Maybe they changed now also my free tier to Ohio. That could be very well.
Our company's account, in fact, their time zone is with Ohio. So that's how I thought like it's their nearest center.
But this is now how you understand that sometimes we don't know these things. These things pop up tomorrow, and you know, our programs don't work because we don't have the right data center for the free tier, and we have to look up, and that makes this thing a little bit challenging. And as I said, you know, you can take a class that teaches you very pragmatic about cloud computing in a chapter X and chapter Y, and then they forget to actually tell you there are all kinds of, this is cloud engineering. There's all kinds of engineering stuff going on in order for you to actually use the cloud. There's more than machine learning or starting up a Hadoop cluster to cloud computing to make it even work, right?
Yeah. And then, Professor,
one thing I would like to, before we run out of time and before other people actually need to leave, not only do we have this compute infrastructure, but the other project is almost finished, and other people can join into that one. And that is called actually Cloud Mesh storage. So we have the same thing for storage, and in storage we have an abstract class and providers. Excuse me. And the providers include, for example, the AWS Object Store, or the AWS S3 Store, an Azure Blob, a Box, Google Drive, and maybe even the local drive. And we do this in the storage class, and the storage class is being implemented again as an abstract class, which we have here, the storage abstract class. And here we say, okay, what do we want to actually have? And in this particular case, we wanted to have an abstraction of a directory, and not just simple files, but we create a directory, we list it, we put some stuff in it, and we get some stuff out of it, and maybe have a tree function. And so this particular group of students has actually implemented this. So what did they deliver? Well, if you take a look and you type in Cloud Mesh manual, you hit this manual, and then here is a link to the rendered form of the manual, and now you can actually see what they implemented. So, and I probably have contributed to this document quite a bit, like for example, the quick start guide, or how do you initialize Cloud Mesh, and what you do. this doesn't mean that this is here is all finished, but it actually helps you because the previous class has already started doing the documentation, and there are the commands that they are given, and for example, there are commands, for example, to do the cloud, and so this is what they implemented. They implemented this command, and this is what we are doing this week. We learn how to write these manual pages, and then implement programs such as this, because it abstracts us from the nitty-gritty details and just go to some simple abstraction that we then look into. So we have, for example, images, and then naturally we have virtual machines. And in virtual machines, the command looks a little bit more complicated.
So, Professor, let me ask, I guess, on behalf of the class, if everyone actually understands like what Cloud Mesh is doing. So I think you're really deep into it, but we
will have a lecture on exactly that.
Okay, I was going to say, I think it's pretty deep, but I don't know if everyone's really on board with like the abstraction layer that Cloud Mesh is doing and making it cloud agnostic. So we will be explaining this. The architecture lecture this week is the first step towards that. Okay, good.
But you're right. That's one of the things, and the problem is you know, we have to start somewhere, right? We can't just expect that you have all the knowledge here in week number 1. We will be gradually pushing you into this activity, and this weekly assignments will help you achieving that.
Yeah, I'm just thinking if no one has experience in Python or cloud computing at this point in time, grasping what Cloud Mesh is actually trying to achieve might be a little bit of a stretch.
Yeah, I hope that after the architecture section that we start this week, it becomes a little bit more clear.
I'm sure it will be, yeah.
And then again, we would like to discuss that with you.
Mm-hmm.
So this was a very rough, but very quick walkthrough. Naturally, if you do a Hadoop project, you can do other things. I have 187 projects, I believe, done by students. So you can spend the rest of the semester looking through projects and not select a single one of them. So, however, this class, the 516 class, has this engineering component to it. It is actually in some aspects easier than other classes that are focusing a lot more on data. Good. So I think I covered what I wanted to cover, and just make sure that you ask now questions. We have 9:30, so make sure that you take the time now out to ask questions. I'm glad to stay here for as long as I have answered all the questions. I'm not going to be teaching you now what Cloud Mesh is, right? That's another lecture. But I want you to understand, sometimes you just pick a project, you think about the project, and then we start discussing about it. I already discussed with other students online about their projects. So you don't have to hold back. You can come up with an idea. You know, what is the idea of your project? And then we figure out how all these requirements fit into your project. So is there already someone who has an idea about the project or would like to discuss the project?
Well, let me ask a question. Like, from your perspective, with the amount of to-do items for Cloud Mesh, what are some of your needs? Like, what is the project really lacking right now?
Oh, right now, testing that the stuff actually works. we actually have an issue identified over the last week in something called security groups. Cloud Mesh, these are cloud security groups. There is a programming bug in there, I believe, that people haven't yet found. The Google Compute provider is implemented in libcloud, but we would like to see if Google has a native Python library that we could be utilizing.
Like Boto 3?
Boto 3 is in Amazon. I'm not sure if Boto 3 is applicable to Google.
But you mean something similar to Boto 3?
Yeah, something similar to Boto 3. But if not, we can actually use and modify the libcloud implementation. And one of the problems we actually had was is that libcloud has some flaws that we didn't know when we started out. Actually, I did know, and then we at one point disbanded libcloud, and then we reused it again, and we found that it's just too complicated to do so. And so what we have done is we have replaced the interface to AWS with Boto 3. We have implemented the Azure interface with the Azure Python library. And you should know that one of the earliest Azure Python interfaces was developed by us, actually, by a student that graduated from our group. And so we are pretty happy to use the new Azure library, which are much better than what we had originally. And they used to be all in libcloud, and we completely replaced libcloud. So as you hear that name libcloud, you may want to just like Google for it if you at one point go for it. So this Google Cloud project, compute project, is probably one of the easier ones. Then the storage project is all implemented, but we really did not do any benchmarks, because what happened is we had one student Box, one student Google, one student AWS, one student Azure, and they didn't compare with each other how much time it actually takes. And the storage project is actually pretty interesting because it's related to NIST. And what we want to do there is not just store the stuff into a cloud, but we want to develop what I call a virtual directory. And the virtual directory stores the file in a virtual folder. And where the file is actually being stored is independent on the provider. So the provider could be, for example, Google, or the provider could be Amazon. But the only thing I know is the file name. And I'm mapping that file name onto a backend storage server. So this way, if you, for example, have a free tier and you can store free data on maybe the Apple Cloud, for example, and you have a free tier on Google Drive, you could combine both of them and say, okay, I create a virtual directory, and in that virtual directory, I have files in my Apple Cloud or Google Drive, and I'm accessing the file name, and based on where the file is being hosted, it's fetched from that particular location.
Well, that's interesting. And so then how would you manage the statefulness of that data? Like, for example, like if you did that, right, how would I know like where to grab that actual endpoint from, whether it's Azure or whether it's...
we do actually have a local copy in what we call a NoSQL database with MongoDB.
Okay, so we can Mongo in the back
which
end.
the mapping is actually hosted. And the nice thing about Cloud Mesh is it actually has a deployment mechanism for MongoDB. It can deploy MongoDB into your machine, and it can actually start it as an unprivileged port on a secure, protected environment, because we make sure that it cannot be accessed from the outside of your computer.
So then, with that being said, then does Cloud Mesh provide me an abstract API key to those providers?
Yes.
So if I have one Cloud Mesh API key, it's then stored inside MongoDB, but then on the other side, Cloud Mesh will go and fetch me the equivalent API key for, let's say, Azure or AWS or...
Actually, we do right now a pretty primitive. This could be one project where we introduce security. I think I even listed this on one of the projects where we, for example, encrypt a YAML file. In the YAML file, we point either to the password, username password thing, or potentially we have a login mechanism to, for example, Azure, where we use the AZ command and have an active login through the web browser with maybe OAuth or some other stuff. But I don't want to necessarily... This can only be done by someone that actually has security expertise or is super interested in this and would like to just deal with the encryption and decryption of that data and figure out how do we do this securely.
I mean, the security part, AWS can manage keys. You've got like SSS, S3, SSS, C, bring your own certificate, and SSE KMS, which is like your key management system. So that's not too difficult, but I see your point. I mean, it would take a lot of knowledge about like how to do the encryption.
Yeah, I don't want to make this an impossible impossible thing for students to do. But one of the things is that we have actually something called Cloud Mesh configuration. And you can integrate some ideas such as this. And one of the things is we have integrated we have integrated a YAML file. And here's an example for such a YAML file. So in order for me to, for example, go out to commit, I have a configuration file where I can, for example, specify the username and the password and API key to get to this. And if I specify this, I can do an interaction with a supercomputer in San Diego. Yeah. If I want to, for example, do a storage service, I can define a storage service that I call simply storage A and put the Amazon credentials in here. I could be creating another directory basically and do storage B and do the same thing. Here I can specify this for Box and so forth and so forth. Here I can do this for Google Drive. So here I have then, I specify the OAuth thirds, and what I just have to do is I have to provide a client ID and a project ID. And we will teach you how to do this in Cloud Mesh. So this is not something that you grab out of the air, right? So this is something we teach you how to do. And then here in the cloud stuff, for example, in Azure, we have, for example, the Azure tenant ID, subscription ID, and application ID that we need to be filling out. And once you have done that, you can actually start this thing from the command line. And the easiest way is actually OpenStack here, Chameleon Cloud. So everybody has this. And what we have done here for you is we created a template. And that template is completely filled out, other than two values: username and password. You put this in here, and we will teach you this next week actually for Chameleon Cloud. You put your username and password in here, and you can start virtual machines right away with Cloud Mesh.
Interesting. That's very clean.
And again, you know, one of the things that we actually have is when we look at the manual. So take this is. I shouldn't teach you the entire class in one session. So, but this is actually quite interesting because I was always bothered. I couldn't remember all of these different things. I mean, it's just like, it's like impossible for me. You know, I'm getting old. And so when I want to, when I want to go to a cloud, I want to have this like this. See, I want to be able to say, okay, initialize my Cloud Mesh. That's essentially setting this up. And then I want to essentially say this is, okay, set my cloud to Chameleon. And then I want to boot a virtual machine. I want to list an image or list a flavor. Now you start thinking, well, you know, if I do this now on Amazon, I have to implement this all in Boto and do all kinds of other things. It takes me like 10,000 lines to do so. But what if I were to be, for example, say, okay, set my cloud now to Amazon. And now what do I want to do? Oh, I want to boot a virtual machine. I want to list the images and I want to list the flavors. That's interesting, right? So now I start thinking, okay, you know, now that I have Azure, I can do the same thing in Azure or Jetstream or Vagrant or Google Cloud.
So then back to your idea of that virtual directory, what would you do in this case? It'd be CMS set cloud equal virtual?
Yeah, so let me see if we already have the manual page and storage defined. It looks like that we may not have the storage interfaces in here yet.
Because I think for my project, I might be interested in looking at like storage policy options. So like when you use like the S3 storage, right, you
Yeah.
pay like a certain amount per gigabyte, right? But
Yes.
then you can have like policy options where I can take that same data and then over 30 days, if it's not being used or frequently accessed, I can move it to like Amazon Glacier for a much lower price point.
I love it. I love it. I love it. This is a really good project. You can leverage Cloud Mesh right there. You have essentially the functions to copy the files from and to that particular cloud. You use Cloud Mesh for that. And then you look into the policy.
Yes.
On what the pricing is. I love it. That's a really good project.
Cool. Okay, I'll take that then.
Yeah, and then so I'm not yet sure. So for some reason we did not publish the pages for the storage project yet. So I would have to look into the Cloud Mesh storage repository to get more information out.
Yes, no worries.
Yeah. So I know we have some manual pages in there. So if you look, for example, at the command here, the command defines really what we currently do. And I believe we don't have implemented the sync command yet, but we have the create directory, get, put, list, delete, and search. But we don't have like the synchronization. The synchronization would be maybe something that you would want to have where you have a bunch of files and you on your local machine, and you would like to sync them with a diff command into the cloud. So so that's one of the things. So an rsync command basically, you know, so this is what the current storage would be, and you could be adding a super command to this, right? And what I found out is that thinking this through first as a command line tool helps the students to restrict their project to a manageable item.
Mm-hmm.
And then you create an abstraction in your head. And this requires the implementation of, for example, services.
Yeah, and so what I was thinking, if you look at the third line there where it says storage -- storage equals service, and it says put source destination. If I were to add a switch to that, it was like -- recursive, then like put like a time frame, like a duration, and say duration equals, let's say 30 days. And then duration destination, or rather like expiration, or how would I say that? I would say next storage tier. Then we could specify things like, you know, delete, or maybe put it in Glacier.
So what I would actually do is I would develop a new command that I don't call storage. So you would be developing here some stuff in here to make
like
sure
archive, yeah, archive
works completely separate. So now you do here the interaction of a single file or multiple file upload and download. So now what you would probably do is you would develop a smart storage. That smart storage has a REST service as a backend, because it's one of your requirements. That REST service is always running. So we will be using Flask for the implementation of that. And then you will be sending commands to that REST service, and it will be including a queue or a cron job that gets fired based on your 30-day activity, and or maybe some other policy that you define. And you would be managing this. For that, you could also use a workflow that we have prototyped in Cloud Mesh. There's also a Cloud Mesh -workflow that could be utilized that includes, for example, a MongoDB a database backend that fires an event based on certain activities. So we could be looking at that. So this can be made arbitrarily complicated. Right?
Yeah, I was thinking more simplistically, like adding a parameter so that, you know, if you have a document, let's say, and it was like just for this class, and you wanted to put it in, let's say, S3 storage. So right now, when you do the put command, it would essentially be there forever. I was going to like add a switch to it to say keep duration equals, you know, some number of days, and that would trigger.
Yeah, I would say yes, that's a good idea, but we can't assume that this particular storage command that we currently have is completely independent from an existing backend service. So what I'm simply saying is yes, we keep the current command storage, but you will be developing something called smart storage.
Okay, got it.
And you copy the same thing here.
Same
You
signature.
make sure that the commands here actually work in your thing too. And if these are broken, you fix them. But and then in your command, you just refer to these commands here and add that other functionality to it.
Okay, that makes sense.
Yeah. And so what you should probably do is you should start working on your project on developing a manual page for your project. So you should be coming up with something like this.
Mm-hmm. Okay. And that'd be the user page, the user manual.
Yes, and you can take a look at any of at this week's assignment that essentially teaches you how to do that that activity. And what you can now do is, as I said, is okay, develop a program that's called with your first name. You don't have to do this anymore. You develop now a program on smart storage. So that's your call. The only thing that I would like you to ask is don't use S storage, right? Don't have two S's one after another.
Okay. Okay.
And I hope you understand why.
Yeah, I got it.
Okay.
Okay.
So whatever you do, don't do that. I will not accept that.
Okay.
It will be rejected. Okay. Question. Anybody else wants to maybe discuss their projects already? So I think this is a really good project. I agree. And you can call me anytime between 8 o'clock in the morning, well, 8:30 probably, to 2 o'clock in the afternoon, at any day.
Cool.
So all the Cloud Mesh people that can communicate me out of band.
And let me ask another question real quick. So when it comes to Cloud Mesh, is it like a competing project to like Terraform?
Terraform was developed much after Cloud Mesh.
Oh, was it? Okay, I didn't know that.
Terraform is so Cloud Mesh is 5 or 6 years old.
Ah, okay.
So all these other programs are just. Well, the thing is I'm not so good in advertisement.
Okay. Okay.
So, plus we have sometimes the problem that some of our codes is being developed by students, and you know, at times, you know, we were somewhat sidetracked by wrong developments over the last year, and then a year before that too. And I made at one point a strategic mistake because we were much further along in the previous version of Cloud Mesh. So if you actually look at Cloud Mesh version 1 and version 2, it had actually more features than the current version of Cloud Mesh.
Huh.
Yeah, any other person wants to discuss their project or project idea? And again, don't be shocked. This is not that difficult. You see a lot of code here floating by your screen. Once you are there for 1 or 2 weeks in this thing, you will see this is not that difficult. Remember that the one student group, they had 3 students working on the code. So if they were to split up the code between the 3 students, each student had to write 300 lines of code. Who is doing the storage project here? Who is this?
Oh, that's Bill Screen. That's me.
What's your name again?
Bill, screen?
Bill, yeah, Bill, you will have a little bit more work than 300 lines.
I imagine.
But therefore, as I said, I'm willing to put some time in. Right?
Okay. Oh, one quick follow-up. So yesterday for the Chrome plugin, I checked to see if Google had published it, and it's still in like review. I don't know what takes them so long, but according to their website, it could take like 7 days. So I just wanted to follow up on that real quick.
Yeah. So you have seen my modification suggestion, right?
I checked it last night. I haven't checked this morning or today.
Yeah. Just so one of the things is, unfortunately, everybody does these things differently. And we are using the most plain possible form of URLs and MISCs. And so if you can get the format, so we, for example, cannot use add online because our BibTeX integration doesn't actually recognize add online as a valid data type in BibTeX.
Oh, yeah. You said that last night. Yeah, I got that. I put it in.
The other thing is we don't need the updated field. We just need to have the month and the year. And
yeah, I took that as well. Yeah, go back to the thread you opened in Piazza.
Which one was this?
It was right there. Help needed for Chrome. That last one, just down right there. Yeah. If you scroll down, I think I put the latest copy of it in, and then.
Yeah, and then yeah. So one of the things we want to do is I actually would like you to send me another email message to. It would be great if I can actually host this on our other web page, on our other GitHub, so that other people can contribute to this. But you also feel free to host this on your side. And I would like to really put this fully in GitHub.
You can fork it. I mean, it's already in GitHub, right? So I just pulled it down and cloned it, dropped it to my desktop, and then opened it up in Visual Studio, and then went and like removed some of the code they had in there that was producing the wrong JSON output. And so then took that and then like saved it and then zipped it up and then dropped it. And see that right there? Yeah, that's the last one.
Yeah. But what I'm saying is I want to have this here in GitHub. So I can host this in GitHub, give you full write access to this, if you want to.
Yeah, so you mean just going to
further develop. So the thing is I think what we want to do is we want to just develop this and then just like push it out, right?
Yeah, I mean, from what I'm seeing, that code is just like really sketchy. I mean, like, I don't know who wrote that original Chrome extension, but some of that code in there was like a little sketchy. I would recommend taking a look at that original source code.
The problem is I don't have time.
Yeah, I got you.
So what I want is you know, I'm even willing to run this in the way you actually taught me to do this, because I didn't know that I can do this. I always thought I had to actually push this out to Chrome.
No, you can run locally. Yeah.
So and then I started thinking, yeah, somehow I need to be developing this. Yeah, and then you just showed me how to do that. So the problem is I don't have much time on doing this. So I will be seeing if I can host this somehow. And
but when you say host it, like, what do you mean? You mean it's going to drop it?
So like, for example, I have something like, I have a secondary project. This project here has something to do with creating our EPUBs here. This is the book manager. This is where I host all the papers and all kinds of other stuff. And so what I want to put in here is I want to put the Chrome extension in here, because I find this so super useful. Because one of the other things is it would be great if you can, for example, add a feature. So you know, for example, about these things that I just posted today, DOI to BibTeX. So somehow I would like to have a feature where I can actually push it in its Chrome extension, the DOI number, and then I get the BibTeX out of it. So that will be another extension.
That's interesting.
And same thing with the ISBN number. So for books. So
Yeah.
I can punch in the ISBN number and then I get actually BibTeX out of it. So now, if you think about this, we have the DUI number, we have the BibTeX, we have, for example, here IEEE Explorer, right? Explorer. So if I type in here, for example, data center, you know, I get probably hundreds of papers on data center. So if you type in here Leszewski, right, you get some papers on that I have written, maybe some papers. Yes, see there's a, you know, and then in here I can, if I click on these things, I can click somewhere on this page, download citation, BibTeX, and I get the citation. So this makes it really super simple for us to work with BibTeX.
Right. So you want to add that to your repo?
Yeah, I would like to add that in some form to this extension. So, but the most important part is I don't have anything that, you know, okay, I'm standing here in this web link. How do I create a reference out of this so that you guys don't have to constantly write the same thing over and over and over again?
I gotcha.
Yeah. So think about the data center assignment that you had. So you had probably 5 or 6 to 10 references.
Yeah.
And if I were to convert that to BibTeX, it will take a considerable amount of time. But if I have that link gets automatically created.
You just click one time.
Click one time is better than writing 10 minutes on this, right?
That makes sense.
Yeah. Okay. Anybody else? Because I think we are now in the second hour. So, but we have already done today as much as another lecture, basically, or another meeting. This will be hard for the residential students to catch up. So I should probably point them to this particular lecture because it was really super useful. And I'm very glad that you brought up the question at the beginning, how do I get this out of GitHub? So I think we explained it again. And if you have, again, an issue with this, don't hesitate to ask. There are also TAs. The TAs will be publishing their working hour tomorrow or the day after tomorrow so that you can get appointments with them in case you were to having some issue that you don't want to address with me. Okay, good. So then let's quit for today. And thank you so much for attending. And I'm so glad about your project here discussion.
Thank you.
I think we have already determined the project for you.
Awesome. Well, thank you. Much appreciated.
So I hope that other people will be starting now to think about this now that you have some more information. And again, there is no right or wrong project. We will be helping you over the next 2 weeks. So let me just double check who is here actually on the phone call. Okay, good.
Awesome.
And if you have any concern that this is too much for the class, call me. It's not too much. As I said, the previous set of students in Cloud Mesh, if you divide the code between them, 330 lines of code. Naturally, it takes you a while to understand how to write 330 lines of code in that framework, but it's not undoable. Okay?
Sounds good.
Good, wonderful. Thank you so much for attending, and it was a fantastic meeting. Thank you.